So if we're taking an inverses, the general idea behind inverse functions, do you remember what that is? Yeah, you switch the x and y, right? No matter if it's tabular or graphical or algebraic, you switch the x and the y, right? So if we're to give you some function, could you calculate the inverse?
Yeah.
Okay, how so? Is that right? Amazing.
Look at that.
Just switch the x and the y. And then what do we do? We do solve for this, okay. Yep. And the cube root of, so that's our inverse, right?
Yep.
So given that the vocal people know how to do it, what if you were given that and it says calculate the derivative
Of the inverse?
of the inverse? Is this a valid method to get to the inverse function? How would you calculate the derivative? Say what?
Power rule?
Yeah. Make it a power rule problem. And it's just a derivative like you.
What does it look like? Is there a certain sign for like the inverse derivative?
There is a certain way to write inverse if it's a function. Is that what you're asking, like notationally?
Yeah.
We could write it like, if this was f of x, we would write this as f inverse of x. All right, and this would be f inverse prime of x.
Okay.
Lots going on there. That's okay. Yeah. A lot of times, so basically what you're, on the next one, I'll show you how they notate it in your book. It makes it just, it's nice. So what's the derivative?
Would you have to use the what?
Kira, do you know what the derivative is? You know power rule? Okay. And what? Okay. Is there an inside there? Do you have to use the chain rule? Yeah, what's the derivative of the inside? 1. You don't have to worry about the chain rule in this case.
So when you have like an exponent and the 1/3, you have two different outside functions?
The 1/3 is the exponent.
But and then the negative 2 over 3.
Yeah, that is the derivative.
Because you have
That's subtracting 1.
Let me see what
Okay. Okay, so you can directly, if it's possible, a direct inverse calculation in the derivative is a valid method. Okay. Let me give you a kind of a primer on the language sometimes it's used. So we're going to consider G of x is the inverse okay, so instead of calling it f inverse, they're actually just naming it different. Okay, and then it might say calculate g prime of x if f of x is x to the fourth plus 10 why do we have to define the domain? Oh, do we need to define the domain? The square root of a square gives us a positive or negative, right? This domain restricts us to just the positive version. So it gives us a single function to worry about. So if this is true, switch, and we get minus 10, and a fourth root. Okay, normally, we would have to put the plus or minus out the front, right? But since we have a restriction to the positive x's, we don't need to worry about that. Does that make sense now? Okay. If we didn't restrict it, we would have to have the positive or negative, which gives us two different functions and two different derivatives. So g of x is, that's an eraser. Yep. Fourth root of x minus 10. Oh boy, now I need it. You see the language difference there?
Yeah.
I mean, it's a big deal. Okay. Are we okay so far? This is hopefully stuff that you know. You know how to calculate an inverse. You know how to calculate a derivative. With the methods we've learned, right? Okay.
What's something you'd use this for?
I think it's the old math teacher eye roll. Searching through the memory banks.
Yeah.
That's a good question. I don't have a direct answer to as far as like what job or some career field.
No, I mean just like something that you would maybe just math or
Like what?
That's what I'm trying to think through.
You wouldn't
Did you say neurochemistry and stuff?
neurochemistry and
I can't think of anything.
if you want to pick up like it.
But so I'll give my standard answer to all this.
Keep going that.
The problem solving that you learn doing this kind of stuff is what you're really gonna use when you get out of here, right?
Wow.
That's the value for most of you.
Ow.
Even engineers, they plug a lot of this stuff in the computer and it's done for you. But you need to know the processes and problem solving in order to be able to do that. Okay, here, let me give you a problem and see if, what you think. Calculate
It's like the smallest thing ever.
g prime at 1, where g of x is the inverse of x plus e to the x.
So how did we use that in the equation?
Okay, when you get here, your root of fourth is supposed to be positive or negative, right? Square root of a squared. But we restricted it to the positive, so it's going to be positive. Right. So the positive. Okay. What's your first instinct here?
Run away.
Try to calculate the inverse, right? Can you?
Yeah.
Okay. I would love to see this.
Yeah, I was like, how?
You just do it.
Is that the,
Can you isolate y? That's the question.
No.
Minus
No.
98. Oh.
no, you
Oh, never mind.
You can't. Okay, we cannot calculate algebraically. Calculate the inverse. Okay. So how do we deal with that?
Artificial.
Look at the back of the book and copy the answer? You suck. No, there is a formula.
Oh, there's no.
Okay, so
Of course there's four.
okay, g of x is f inverse. Okay, we gotta define that.
Is that just a dot next to the one?
What?
That's a negative one.
That's a dot. Calculate the g of x for f smiley face. Yeah.
Okay, g prime of x is
Oh, yeah.
1 over f prime of g of x. That's your formula.
Is that for all inverses too?
Yeah, it works for all of them as long as, well, let's put our qualifiers in there. F of x is differentiable.
Why then?
Okay, so how would I apply this to that function?
What do you mean?
Okay. Do we know what the inverse is?
No.
No, we don't. Okay, but we aren't asked for the inverse, we're asked for the inverse at 1, correct?
Yes.
Okay, so what is, so we need g prime at 1 is 1 over f prime of g of 1. Well done. G at 1. Okay, can I calculate the inverse at 1? Okay, if the inverse x value is 1, what's,
That means the
Y
y value.
bingo, that's the y value, so you switch the x and y, that's the y value up here, correct?
Yes.
Okay, so this is the x in the inverse is the y in f of x. So how do I calculate? Here's another way to put it. The x in g, right, is 1. That means the y value in f is 1. So I need to figure out the x of f to get the y value of g, correct?
Mm-hmm.
Okay, so how do I do that?
Yeah.
1 equals the function. Right. So we're using f of x and all of its properties to figure out the derivative of the inverse. So does anybody know what that x value is?
X value what?
What x value in this? Give this one. It's not something you can just algebraically calculate, so you have to think it through logically. What's your first option for a plug and chug? That's a really easy number. 0. Plug 0 and what do you get? 0 plus.
Anything
One.
with a zero probably is one.
Yeah, so x is 0.
How do you draw that? Graph it in
What graph?
for that little table? Is it a bunch of stuff like that? Let's say x is inverse.
Yeah, so we know that we need g prime at 1,
Yeah.
right? So in the formula, that tells us that we need g at 1. So the x value is 1 in the inverse.
Can we just get rid
That
of
means that's the y value in the original. So if I plug 1 in for the y in the original, I get to solve for x. And that gives me my x value, or my y value for the inverse. Right, you're kind of playing the game of inverses.
So that
So g at 1, the output is 0. What?
Can we just get really lucky that x equals 0?
No, that's not luck, it's just math.
Is it gonna work out like that?
Not necessarily. It's just a number. Whatever number this outputs goes back in your formula. Okay,
Oh, because you want this.
right. It gives you your y value for the inverse. What is f prime of x? Because that's what we need, right? F prime of x is 1 plus. Okay, and then we need f prime at 0 is
0.
2.
Thank you for being able to add. E to the 0 is 1. 1 plus 1 is 2.
Alright.
Do I need to send you to Miss Magruder's Math 1 class?
Please.
Probably.
So what is g prime at 1? 1/2. So this is another one of those process problems. Right? Find the y value that you need. Plug it in. Derive f. Plug it in. Okay? So you're manipulating an inverse with the formula. Okay? It takes a little bit of time to get used to that one, because it is kind of a roundabout process. That's all we have time for on that one. There are 6, so you had 6 trigonometric derivatives. Okay, it will earn you a point at minimum on the AP exam if you remember the inverse trig derivatives, if you memorize them. So, just a quick note on trig,
How will they ask me?
inverse derivatives. We'll put memory cards to this, but here's an example of one of them. Yeah, it's weird.
That is not pleasant.
No, it's not pleasant. Okay. You could also do the cosine. And the nice thing about these, again, you have sine cosine relationship.
Yeah.
You have some negatives floating around. Well, there you go. That's all. It's cosine and sine are the same except for a negative. Kind of like the derivative of cosine is negative sine. So, okay, there are 4 more of those. I'm not going to write them down. But all I can tell you is that memorize them because you learn a point. I'm pretty sure Google Classroom's updated, but if you want to write a whole practice down, it's not due until Thursday because we have the career fair.
No, no.
All morning.
Morning and then we have study session.
Oh yeah, we do have study sessions tomorrow. Come and practice derivatives.
I literally only have 2 AP classes. I have this in micro. Because I
I made the same here. Dude, I'm sorry, I did some of the not your job.
Hey.
put your